4.6, page 210, Arithmetic Sequences. In this lesson, you will learn how to write the terms of arithmetic sequences, how to graph an arithmetic sequence, and how to write an arithmetic sequence as a function. Let's talk about, first of all, what a sequence is. A sequence is an ordered list of numbers, like you see an example sequence here. Each number in the sequence is called a term. So here's my sequence. Now the numbers 5, 10, 15, 20, 25, and so on would be called terms. Each term has a specific position in the sequence. Like the term 5 is in the first position, the term 10 is in the second position, and the term 15 is in the third position, and so on. Now, an arithmetic sequence, the difference between each pair of consecutive terms is the same. So the key word there is difference. Difference indicates subtraction. Now remember, subtracting is the same thing as adding the opposite. So basically the way I teach this is if you see an addition or a subtraction problem, because subtracting is the same as adding the opposite, you have an arithmetic sequence. Now the difference is called the common difference. Each term is found by adding the common difference to the previous term. Like if you look at this sequence, it's clearly an arithmetic sequence. And here's how I can tell. 10 minus 5 is 5. So if you look, if I add 5, I get 10. If I add 5, I get 15. If I add 5, I get 20. So if I try subtracting from the larger term to the smaller, I get 5. And if I add that 5 to every term, I keep on getting the next number. 5 would be the common difference here. An ellipsis, the dot, dot, dot that you see here, is a series of dots that indicates an intentional omission of information. Now, in mathematics, the dot, dot, dot means and so forth. It means that there are more terms in the sequence that aren't shown. Let's talk about extending an arithmetic sequence. This is one of your I cans for this lesson. Let's write the next 3 terms of this arithmetic sequence. Now you notice they told you it's an arithmetic sequence, so we know it has to be an addition or subtraction pattern. I just got to find the pattern. So as I look carefully at this, I notice that if I take away 7, take away 7, take away 7, I keep on getting the next term in the sequence. So the next 3 terms would be if I take away 7 from 28, I get negative 35. If I take away negative 7 from negative 35, I get negative 42. And if I take away negative 7 from that, negative 49. So this sequence is just taking 7 away from each of the next, or each term. Take away 7 from each term. The book is just calling it adding negative 7. I just said take away 7. Okay? What I'd like you to do is find the next 3 terms of the arithmetic sequence for these 3 questions. Pause the video and try that. Okay, you're back. So for the first one, the common difference clearly here is 12. We're adding 12 each time. So if I add 12 to the next 3 terms, I'd get 36, 48, 60. Here, the common difference, I keep on adding 0.4 each time. So if I add 0.4 to the next 3, I would get 1.8, 2.2, and 2.6. And here the common difference, we're taking away a quarter each time. So if you continue taking away a quarter, the next 3 terms would be 3, 2 3/4, 2 1/2. Another I can for this lesson is graphing an arithmetic sequence, and that's easy to do. To graph a sequence, let the terms position, okay, we talked about position earlier, the position number is the x value. And then the term itself is the y value. So for example, when you look here, graph the arithmetic sequence 4, 8, 12, 16. What do you notice? Well, first of all, this is term 1, term 2, term 3, term 4. What this is saying up here is these are the x's and these are the y's, so they made a little table here. Okay, so one of the points, let me get my highlighter out, one of the points here would be the point 1, 4. So you can see they graphed 1, 4. And then another point would be 2, 8, and they graphed it. And then another point would be 3, 12, and then another point would be 4, 16. What do you notice? Well, I notice these points make a straight line. This is something I would get in my notes. Arithmetic sequences always create a straight line. If it's not straight, it can't be an arithmetic sequence. Which kind of gives away the next thing. Identify an arithmetic sequence from a graph. Well, we just talked about that. It's got to be straight to be an arithmetic sequence. So, does this graph represent an arithmetic sequence? Well, these points do look straight, and let's just analyze right here the y values. If we have a common difference, then we know it would be an arithmetic sequence. Let's look. We're going down 3 from 15 to 12, down 3 from 12 to 9, down 3 from 9 to 6. This is definitely an arithmetic sequence. Okay? There's a common difference. We're going down 3 each time. What I would like you to do is pause the video. Why don't you try numbers 4 and 7? I want you to graph 4, what do you notice, and then answer number 7. Okay, so for number 4, when you graph it, you're going to see this. So the sequence was 3, 6, 9, 12, and 3 was in position 1, 6 was in position 2, 9 was in position 3, and 12 was in position 4. So I plotted those points, and what do you notice? Well, if it's an arithmetic sequence, it must be a straight line. And it is in this case. So this arithmetic sequence is creating a straight line. For question number 7, it's a little hard to tell because this picture is a little distorted when I copied it, but you notice these points aren't creating a straight line, these are creating a curve. So I know right now this can't be an arithmetic sequence, and there's another way I can show you why. Look at the y values. Okay? 2 to 4, I add 2, but then from 4 to 7, I add 3, and then from 7 to 11, I add 4. Do you notice? I do not have a common difference. I'll put a red X to represent that. I don't have a common difference. This graph is not an arithmetic sequence. And then let's go over the next major I can from the beginning of the video. Writing an arithmetic sequence as a function. I'm going to skip over this part. This explains how you get the formula. I don't know that we need to spend time on that. Here's what is important. If you want to write an arithmetic sequence as a function, this is what you do. You let the nth term of the sequence equal the first term plus the common difference times the number of terms remaining. Now you might be like, well, that sounds complicated, okay? It's not complicated. I'm going to show you, this is abstract. I'll show you with whole numbers in a minute, but write this down. This here is saying if you have n terms, take the first term and add it to the remaining terms times the common difference. If you do that, you will have a function for that situation. And if you're thinking, that still seems hard, okay? After you write this down, pause the video, write it down, then we're going to go through it. So let's go through it for this example problem right here, okay? Write an equation for the nth term of the sequence. Okay, so we're going to follow exactly what I said here. The nth term should equal, let me highlight as I'm doing this, it should equal the first term, which is 14. So I have 14 added to the remaining terms. Well, I have n minus 1 terms remaining because I got to take away one of the terms. There's the first one. I have n minus 1 terms remaining times the common difference. You notice how this is going down 3 every time. Okay? There's my formula. Now, I'd give you a C for that. If you want an A, distribute and simplify. So let's do that. So when I distribute, I get negative 3 times n is negative 3n, and negative 3 times negative 1 is positive 3. And then when I simplify this thing, I get negative 3n plus 17. There's the formula for the nth term of the sequence. Now, find a to the 50th. So if I want to find the 50th term, you don't have to subtract 3 to this thing a whole bunch of times. You just use this little formula now. Okay, 50th term. Negative 3 times 50 plus 17. That would be negative 150 plus 17. That's negative 133. Okay, you don't want to have to find the 50th term by doing this one at a time. You just use the formula. Why don't you go ahead and try writing an equation for the nth term of each of these sequences and then find a to the 25th. I misspoke. I should have said the 25th. I don't want to make it sound like an exponent. I want you to find the 25th term of the sequence. So anyway, for a, here's the first term, 4, plus I have n minus 1 terms remaining, and can you see how each time we're adding 1 here? Okay, so times 1. Distribute and simplify. So if I want to find the 25th term, that's easy. The 25th term of this sequence would be 25 plus 3, and that's 28. For the next problem, the first term is 8. I'm adding n minus 1 terms, and can you see how the common difference is 8 each time? I keep on adding 8. Distribute, simplify. Okay, if I want the 25th term of the sequence, 8 times 25 would be 200. And then for number 10, okay, the first term of the sequence is 1, plus n minus 1 terms remaining, and you notice how we're going down 1 each time. That's why I have a negative 1. Distribute, combine like terms, there's my sequence. If I want the 25th term, negative 1 times 25 plus 2 is negative 23. That'd be the 25th term of the sequence. This is saying you can rewrite an equation for an arithmetic sequence in function notation. Instead of using a to the nth, I should call it the nth term of the sequence, I can just use f of n instead of a sub n. Okay? So that's how it would look. You notice it's the same statement, it's just instead of having a sub n, we have f of n. Okay? Finally, let's talk about writing real-life functions. So in this problem, online bidding for a purse increases $5 for each bid after the initial $60 bid. So we made a table. First bid was 60, second 65, third 70, fourth 75. First of all, do you notice it's an arithmetic sequence? So let's write our function. The nth term would be the first term, which is 60, plus n minus 1 terms remaining, and we keep on adding 5 every time, so times 5. And let me simplify that by distributing, and I get 5n minus 5 here. So the nth term of the sequence, a sub n, would be 5n plus 55. Okay, let's graph this. So I'm going to take those points and graph it. So you notice here I labeled my graph with the title, Online Bidding. Here's the bid amount in dollars by tens, and here's the bid number. So the first bid was 60, second 65, third 70, fourth 75. And you notice this is arithmetic sequence. It's creating a straight line. Finally, the winning bid was $105. How many bids were there? Well, that means 105 was the sequence number, and I have to solve this, and n would tell me how many bids we had. So to quickly solve it, take away 55, and 5n would equal 50, and divide by 5. It must have been the 10th bid that was the winning bid. I'm going to pause the video here. If you have questions, make sure you ask in class.